So in the last session, we were discussing the turning effects of the forces. The force can change or rotate an object. So by applying a force, we can produce a clockwise or anti-clockwise rotation. And we discuss the definition. The turning effect of the force about a pivot is called a moment. An everyday example like opening a door, loosening or tightening by using a wrench or a spanner, or lifting a load with wheelbarrow, or lifting the heavy load by using a crowbar. And to calculate the moment, the turning effect, it can be calculated by using a formula: force multiplied by distance, perpendicular distance from pivot, and that's the point where the force is acting. And if we want to increase the moment, we can apply a higher force, or we can increase the distance of force from the pivot. So this is a word example. A boy looses the nut using a 0.2 meter long spanner. He applied a force of 50 Newton. Calculate the moment of the force. So in this example, if the picture is not given, you cannot mention a clockwise or anti-clockwise. So you don't have to mention a direction. What is the resultant moment here? A boy is applying a force of 50 Newton. The distance he's holding the spanner having a length of 0.25 meter. So what is the turning effect produced or the moment produced by this boy? So that is force multiplied by distance, 15 to 0.25. That's equal to 12.5 Newton meter. If length is meter, then the answer will be Newton meter. If length is in centimeter, then our final answer will be Newton centimeter. Then what is the principle of the moment? The principle of the moment state that if object is in equilibrium, if object is balanced, the term equilibrium here refers to balance. So what is the principle of equilibrium or moment? That it state if an object is in equilibrium, a principle of moment state, if an object is in equilibrium, the sum of clockwise moment about any point is equals to sum of anti-clockwise moment. And we did this example in the last session. So example, if here is an object, we applied a force of 5 Newton. Distance from the pivot was 4 meter. We applied another force of 5 Newton and the distance was 4 meter. We calculated the anti-clockwise moment, that is 5 multiplied by 4. So that is equals to 20 Newton meter anti-clockwise. And we calculated the clockwise moment, that's 5 multiplied by 4. So that's also equal to 20 Newton meter clockwise. So what was the resultant here? The resultant moment, because the two moments are in opposite direction, so resultant was 0 Newton meter. So according to principle of moment, if the clockwise moment, the total clockwise moment is equals to total anti-clockwise moment, then the object will be balanced or object will be in equilibrium. That this object will not rotate either clockwise or anti-clockwise because the moments are balanced. Is it clear? The principle of equilibrium which say that object will not rotate, the object will be balanced if the clockwise moment is equals to anti-clockwise moment. So example, are they in equilibrium? Yes or no? That's good. They're not in equilibrium. Why they're not in equilibrium? Because one of the moment is higher than the other one. And what are the conditions for equilibrium? This is very important. In exam, you will find many times this question they ask, state the conditions of equilibrium. So what are the conditions for object to be in equilibrium? So when a beam is balanced, we say that is in equilibrium. And if an object is in equilibrium, there are two conditions. Number one, the forces on it must be balanced. Means no resultant force should be there, and there should be no resultant turning effect. So example, so what does it means that no turning effect or no resultant moment? Example, if I say here is an object, this is a pivot, there is a force from the pivot that is 20 newtons upward. There is a force of 10 newton from the left hand side, and there is a force of 10 newton from the right hand side. The distance between the pivot and the force is equals to 3 meters from both sides. Okay. Now what we have to do, we have to identify whether it is in equilibrium or no. So how we can work out it is in equilibrium? To know it is in equilibrium, there should be no resultant force, and there should be no resultant moment or turning effect. So the 10 newton force from the left hand side, which direction it will cause a moment? Clockwise or anti-clockwise? A 10 newton force which is from the left hand side, which direction it will cause a moment? Anti-clockwise. And what is the total moment produced by this force? 10 is a force and distance is 3, so 10 multiplied by 3, that's equal to 30 newton meter anti-clockwise. What about this 20 newton force? There is a force of 20 newton which is acting on the pivot. How much moment this will produce? It will produce 0 newton meter. Why it will produce 0 newton meter? Because there is a force, but what about the distance from the pivot? Because it is acting on the pivot, so its distance is 0. Because it does not have any distance, so force is there 20, but because there is a distance 0, that's why. So whenever force is acting on the pivot, it does not cause any rotation. And when we calculate the moment due to a force of 10 newton acting towards from the right hand side downward, so that will produce 30 newton meter clockwise. And according to equilibrium, number one, there should be no resultant moment, like resultant moment should be 0 and resultant force should also be 0. So what we do, first we calculate resultant moment. So what is the resultant moment? A 30 newton anti-clockwise, 30 newton clockwise, and there is this one is 0, so we don't have to use at all. So the resultant moment will be 0 newton meter. And what about the resultant force? So about the resultant force, a 10 Newton is acting down, because when you compare the force, you don't have to bother about distance. 20 Newton is up, 10 Newton from left hand side down, 10 Newton from right hand side is also down. So 20 minus 10 minus 10. So what is the result? The resultant force is 0 Newton. So when you have resultant moment 0, when you have resultant force 0, what we call that this object is in equilibrium, and these are the two conditions for object to be in equilibrium, that there should be no resultant force and there should be no resultant turning effect or moment. Is it clear? So what we can say this object, that this object is in equilibrium or this object is balanced. So a word example, the diagram shows a uniform half meter rule. So what we need in the question, what is the weight of this metal block? Whenever you solve a question, yeah, this is the second, Abdullah, the two conditions for object to be in equilibrium, that there should be no resultant force, there should be no resultant moment. So we want to work out the weight of this metal block. So weight of this metal, weight is always acting downward. Okay. So whenever these type of questions is there in exam, what is your always assumption? What will you assume? That you will assume that object is in equilibrium. And when object is in equilibrium, anti-clockwise moment is equals to clockwise moment. And number two, no resultant force, or we can say the upward forces, is equals to downward forces. As these are the conditions for object to be in equilibrium, that no resultant moment, or we can also say that anti-clockwise moment is equals to clockwise moment, and the second condition, there is no resultant force, or we can also say the upward forces equal to the downward forces. So now in this question, we need the weight of this object, a metal block. So whenever a question is there related to a moment, what is your assumption? Your assumption is that it is in equilibrium. When it is in equilibrium, it means the anti-clockwise moment is equals to clockwise moment. So a force of 100 Newton, which direction this will cause a rotation? A weight of 100 Newton, which direction this will cause a rotation? So it will cause an anti-clockwise. And a weight of the metal block, which direction this will cause a rotation? From the pivot. This will cause a clockwise rotation. And because we always assume these type of question, we assume that always the anti-clockwise moment is equals to clockwise moment because we assume it is balanced or it is in equilibrium. So what is the anti-clockwise moment here? There's a force of 100 multiplied by distance. What is the distance from the pivot? That's 15. And a clockwise moment, the force is weight of the object multiplied by distance from the pivot, that's 20. So when we solve this, this 20 is multiplied, other side it will be divided. So it will be 100 multiplied by 15 divided by 20 is equals to weight. When we solve, this will be 5 multiplied by 15. So that is equals to 75 Newton. So weight of this object is equals to 75 Newton. Is it clear, this example? So whenever a question is there related to a turning effect and we want to find a distance or a force, we always assume that object is balanced or it is in equilibrium. How we know it is in equilibrium? If you see this question, the diagram shows a uniform meter rule which is balanced at the midpoint. So this object is balanced, it is not moving. That's why we use the clockwise moment is equals to anti-clockwise moment and calculate the unknown weight. And using a moment idea, you can identify the objects which are heavier and objects which are lighter. Like example, you have a beam, and it is pivoted from the center. And two objects are placed, object A and B are placed at the same distance from the pivot. So when two objects are placed same distance from the pivot, like example, this is placed 2 centimeter, this is also 2 centimeter, and it is balanced. So what we can say in this scenario, if two objects are placed at the same distance from the pivot, so we can say that weight of the objects are same. So we can say weight of object A is equals to weight of object B. So when two objects are placed at the same distance from the pivot, we can identify if they are applying the same force. So if they are applying the same force, it means both objects have the same weight. But if it was other way around, this is a beam and this is object A which is closer to the pivot and object B is away from the pivot. Can you identify which object is lighter? Which object is lighter, A or B? And keep in mind the beam is balanced. The beam is balanced. Which object is lighter? The correct answer is B. B is lighter object and A is heavier object. How you can work out this? Example, I will use a number to explain the idea. Example, A is 30 newtons and B is only 15 newton. A is placed 1 centimeter away from the pivot and B is placed 2 centimeter away from the pivot. When A will produce a rotation, it will produce an anti-clockwise rotation. So 30 multiplied by 1. So 30 multiplied by 1, that's equal to 30 Newton centimeter. What about B? A force of 15 Newton multiplied by distance is 2. So 15 multiplied by 2, that's equal to 30 Newton centimeter. So when the beam is, this beam will be balanced because the moment produced by A is equals to moment produced by B. So whenever we want to balance the moment, because the object is lighter, so we should place away from the pivot so it will be balanced with a heavy object. So heavy objects are placed closer to the pivot and lighter objects are placed away from the pivot so they can balance their moment. Is it clear, this example? So another example, if you have a beam and here's a pivot, you place two objects A and B. Can you identify which object is heavy? Is it A or B? So which object is heavy? B is heavy object because it is closer to the pivot. So it will, and A is lighter object because its weight is smaller. The size, don't bother about the size because they might have a different size depending on their densities. So whenever we want to balance the beam, the heavy objects are placed closer to the pivot and lighter objects are placed away from the pivot to produce the same turning effect. Now coming back to this example, what will be the weight of this block? Which object is heavy? A metal block or this 100 Newton? Which object is heavy? A weight of 100 Newton or a metal block? So a weight of 100 Newton is heavy because it is closer to pivot, and already we calculated this value in the previous exam. It was 75 Newton. So whenever we want to balance the object, the heavy objects are placed closer to the pivot and lighter objects are placed away from the pivot. So because the beam is balanced, it is in equilibrium. This is producing anti-clockwise rotation. The metal block is producing clockwise. As the beam is balanced, the anti-clockwise moment will be equal to clockwise. An anti-clockwise moment, the force is 100 and the distance from the pivot is 15. Clockwise moment, the force we don't know, the weight we don't know, and the distance of this metal block from the pivot is 20. So if this 20 is multiplied, other side it will divide. So it will be 100 multiplied by 15 divided by 20. And when you solve 100 multiplied by 15 divided by 20, that will come out as 75 Newton. This is 75 Newton. The other one is 100 Newton. Then what is the meaning of center of mass of center of gravity? Basically, the force by which Earth is pulling the object. What we call that force? The pull of the gravity. What we call that pull of the gravity? Is having a specific name. So the pull of the gravity is actually known as the weight of an object. So the pull of the gravity or the weight of an object. So there is a point where the earth is pulling the object. So the point, the position where earth is pulling the object, that position or that point is known as center of gravity or center of mass. And center of the gravity and center of mass, it's not necessary it will always be in the center. It depends on the distribution of the mass. Like example, all these examples, the center of the gravity or center of mass will be there at the center, because these are uniform objects, they have equal distribution of the mass. So the point where the weight of an object act, we call that point as a center of the gravity or center of mass. But I mention again, it does not mean it is always at the center. Example, some objects are not having a regular means distribution of the mass or uniform distribution of the mass. This object, like this is an object which is not having a uniform distribution of the mass. So what could be the likely center of the mass? Because this object, more mass is there at the bottom. This object, more mass is there. Equal distribution of the mass means like equal distribution of the particle. When I say like there are particles 1 2 3 4, 1 2 3 4, so particles are evenly distributed. So where the center of the mass will be there, it will be there in the center of the object when the particles are evenly distributed. But sometimes the particles are not evenly distributed. Like I give that example, say a hammer which is having more particles at the bottom and few particles are there at the top. So what will be the likely region? The likely the center will be here, but the center of the mass or center of gravity will not be here. Why? Because most particles are at the bottom, so center of the mass or center of gravity will be there in the bottom side. Is it clear, the idea of center of the mass and center of the gravity? So center of the mass and center of the gravity is the point where the earth is pulling the object, and it is depending on the distribution of the particle. So the side where we have more particle, that side likely will have the center of the gravity or center of mass. So what will be the correct position of center of the gravity or center of the mass? A, B. What is the likely position of the center of the gravity or center of the mass for this object? So it will be B, because most of the particles are distributed at the top. That's why the center of the gravity will be higher. So center of the gravity is a point where earth is pulling the object. And for the objects which are regular, as you can see, those objects which are regular and uniform, the center of the gravity or the center of the mass will be there at the center. This is the experiment that we'll discuss in the next class, how to get the center of gravity of irregular object. But now I'm discussing things related to center of the gravity. So example, what is the position of center of the mass of a tractor? Can you identify? Or the tractor is there, there's a tractor A, B, C and D. What could be the likely position of center of the gravity and center of mass? Yeah, that's good. D is the likely position because most of the matter of the tractor is there at the bottom. That's why it will have a center of the gravity near the base. Then the stability of an object. The term stability means when you apply the ability of an object to return to its original position after a push and then release, we call that as stability. Like if an object can return back to its position by itself, we say the object is stable. If the object does not return back to its original position, we say object is unstable. Like you have a glass, you apply the force, you tilt the glass, so when you apply the force, you tilt the glass, and when you release your force, if the glass return back to its original position, if the glass return back to its original position, we say the glass is stable. But if the glass does not return back to its original position, we say the glass is unstable. So if an object can return back to its original position, once the force is released, we say object is stable. If it does not return back, we say object is unstable. But this stability depends on two things. It depends on the position of the center of the mass. So if we want to increase the stability, we should lower the center of the gravity. Like example, you have a bus and you have a car. A bus is having a higher center of gravity and a car is having a smaller center of gravity. If you try to take a sharp turn by using a bus and a car, which one is likely to topple? Which one is likely to rotate or flip or topple? So a bus is likely to rotate or topple, and a car, so it means the bus is less stable and car is more stable. And what could be a reason for that? What is the reason? Because the car is having a lower center of the gravity, whereas bus is having a higher center of gravity. So if we decrease the center of gravity, the object become more stable. So and also we can increase the base area. That's why like the Formula 1 car or race cars, you will find these Formula 1 cars or race cars, they design low as possible. What is the reason why the Formula 1 car design is low as possible? So that they will have a lower center of the gravity. So the car or the bus, that car will not topple when it is taking a sharp turn. Is it clear? The relation between the stability and center of gravity as well as the base area. So if we increase the base area, we will increase the stability also. The object will not topple. So racing cars, they have low center of gravity and wider wheelbase to have a higher stability. Which object is more stable, A or B? Which tool is more stable, A or B? This is a base area for A and this one is a base area for B. So B is more stable because B is having a greater area as compared to that of A. So which glass is more stable, A, B, C or D? So why D? Because D will have a lower center of the gravity and D will have large base area. Is it clear? The concept of stability. So today what we discuss the turning effect, the moment. So we discuss the stability depends on many factors such as base area and the position of center of gravity. So the start was the turning effect, then the definition of the moment, that when force applied and rotate the object, we call that as a turning effect. Example like opening a door, loosening or tightening a nut using a spanner or a wrench, wheelbarrow, lifting a wheelbarrow, or crowbar using a heavy lifting a heavy objects. We want to if we want to calculate a moment, we can calculate by force into perpendicular distance. And if we want to increase the moment, we should increase the force, we should increase the distance which we are applying from the pivot. This was a bird example we did. Then the principle of the moment. When moments are balanced, the clockwise moment and anti-clockwise moments are balanced or equal, the object will not rotate, and we call that as principle of moment. And equilibrium, it is very important you learn the condition that there is no resultant force and no resultant moment when the object is in equilibrium. And when we place the objects, the heavy objects are placed closer to the pivot and lighter objects are placed away from the pivot. The center of the gravity, the point where the weight of an object acts, that's called center of the gravity. And the stability of an object depends on the position of center of gravity as well as the base area. We should lower the position and we should increase the base area to increase the stability of an object so it will not topple. So this was what we have discussed today. Any question related to the class? Tomorrow we'll do questions from the past paper related to this topic, and we'll do exercise. So have a nice day, everyone. I'll end the session and share this with you.